Welcome back to the Learning Studio. You're watching our mathematics series, where we break down the core ideas that shape science, technology, and artificial intelligence. If you're new here, don't forget to follow us by clicking the link below. And remember, the full playlist is available in the description so you can catch every episode in order. Today, we're exploring one of the most fascinating areas of modern mathematics: graph theory and network science. It's the study of connections, and as you'll see, connections are at the heart of how our world and even our minds really work. Let's start with a simple puzzle from the 18th century, the 7 Bridges of Königsberg. People in the city wondered if you could walk through town crossing each of its 7 bridges exactly once. Mathematician Leonhard Euler looked at this problem and realized it wasn't about bridges or paths at all. It was about connections. He reduced the city to points and lines, nodes and edges, and invented a whole new branch of mathematics: graph theory. Fast forward to today, and that simple insight powers everything from Google search to Facebook to advanced AI systems. Core concepts explained simply. Here are the essentials of graph theory and network science. Graphs. A graph is just a collection of nodes or vertices connected by edges. It could represent friends on a social network, cities connected by roads, or even neurons in your brain. Paths and connectivity. These study how nodes are linked, whether information can flow, and how networks stay connected or break apart. Networks in the real world. Graphs grow into large networks like the internet, airline routes, or ecosystems. Network science studies how these complex webs behave, evolve, and scale. Graph neural networks, GNNs. In AI, graphs aren't just abstract structures, they're data. GNNs allow deep learning models to work directly on graph-structured data, powering recommendation systems, drug discovery, and knowledge graphs. Why it matters in AI and technology. Graphs are the hidden structure of our digital age. Social media platforms use graph theory to recommend friends, groups, and content. Search engines rank web pages by studying the graph of links. In machine learning, GNNs push the frontier of AI by capturing relationships that traditional neural networks can't. Even in biology, graphs are used to study protein interactions and disease networks. Wherever there are connections, graph theory provides the language to understand them. So graph theory and network science teach us that the power of systems doesn't just lie in their parts, but in their connections. Whether it's people, computers, or ideas, the web of relationships defines the whole. In our next episode, we'll go even deeper into topology and geometric deep learning. Here, we'll see how mathematics studies shapes, surfaces, and spaces, and how these ideas are reshaping modern AI through manifold learning and shape analysis. Don't forget to follow us by clicking the link below and check out the full playlist in the description. Each episode reveals another piece of the mathematical puzzle, and the bigger picture is only getting more exciting.